So guys, we are going to learn about Dijkstra's algorithm, and I'm going to make it so crisp and clear for you that you will never forget this algorithm. And this is not about how to rote learn this. This is actually about how to understand that why this algorithm exists in the first place. So by this time, I hope that you remember what is the BFS or what is the DFS traversal. Okay, now BFS and DFS doesn't actually depends on the weight of the traversal in a particular graph. It's mostly about the connected components, and this is mostly a search algorithm where according to the question you want to find out ki okay, will I get my answer in a BFS or will I get my answer in a DFS. Maybe I just want to search level wise, so I will preferably use BFS. If I want to search a particular node, depth wise, because I know that maybe that there is a chance, but it depends on the question, right? Like you are building maybe a word, and you know okay, after A B O will come, like in my name, so then you will go in that particular way. So whatever, but in this question the weightedness is important. So let's assume that, and anyone can guess the brainer ki okay, here I am seeing that 0 to 1 and 1 to 2 is 5, 0 to 2 is 8. So of course I, instead of going like this, I will go like this, and 0 to 1 anyways, this is the shortest path. If I go like this, then it makes no sense because it will be 11. I'll go 0 to 1 like this. Now what happens if I so one thing is that I can create an array and I can keep the actual weights that I am encountering while I am traversing. Okay, so this is for 0, this is for 1, this is for 2. And once I have visited all the nodes, anyways I will compare the weights with the minimum value. It should be the minimum value, and if I encounter a minimum value, then I will update it. It's very simple. So let's assume that we are simply traversing this, maybe according to BFS. Now this also depends on how in your adjacency metrics you are traveling. Suppose you have given that for 0 you have this is basically the vertex and the weight. So this will be 1 and 2, and this will be 2 and 8. And suppose in the question, instead of this, now it's mentioned like this. Okay, same thing, but just the order is different. Now since the order is different and you are traveling without considering this particular weight, what will happen? Just see. Suppose I put my 0 in the queue. Okay, I will pop that particular 0. So now I have 0. And now for the with the first case, so this is case 1. In first case, I will definitely first go to 1 and then I will go to 2. So I will check for 1. For 1 I will get 2. So I will populate here 2. And then for 2 I will check. I will get 8. I will populate here 8. Because anyways up till now these both were infinity. But now it will be cancelled. This is anyways 0. And I will put this 1 in the queue and then this 2 in the queue. Okay, just like maybe a BFS thing that we did. So now in the queue we will have 1 and 2. Then again in the, so this is the first iteration. Then in the second iteration I will get 1. Now with the 1 I will see okay, 1 has 2 and 0. 0 is already visited. So I will visit 2 and I will see that okay, 1 is anyways 2. So 2 plus 3 is 5. And for abhi yahan pe 8 hai, so I will cut this and I will make this 5. Okay, and that's it. And then I will like this is removed from the queue and now 2 is left. 2 will come, it will see 0 is visited, 1 is visited, so nothing. So here if we see your 0 is coming 0, for 1 it is coming 2, and for 2 it's coming 5. Well and good, our algorithm actually worked. But let's suppose our input is in this manner. So now what will happen is, after visiting the 0, I'm not writing, so after visiting 0, I will, in my queue will look like this, 2 and 1. Okay, so first we will process 2. Once we are processing 2, we will see over here, and our this one where we are actually storing the weight. So this will be 0, this will be 2 and 8. Okay, we are processing 2 now. 2 we will see, okay, 0 already processed, so now 1 is left, and I will do 8 plus 3, which is 11, and 11 is less than 2, so I will let it be, and now my 2 is visited. Then 1 will come, and 1 will check that, okay, there 0 is already visited, 2 is already visited. So what will happen is, this is the answer that I am getting. Instead of 0 to 5, I am getting 0 to 8, and the same algorithm I am applying. So the problem is, if I am randomly visiting the algorithm, visiting the vertices, I am not getting the accurate result. So that is the reason. And if you see why with traveling with 1 worked, because 1 was having the lesser weight as compared to this 2. Even if you increase this particular graph, maybe you increase the vertices, the smallest weight holding vertex, if that vertices, if vertex, if that is actually put in the queue, processed in the queue first, then there are chances, not chances, there is 100% chance that whatever it is connected to will be showing the shortest path. Okay, because we are marking the this has visited. If we do not mark this as visited, it will be continued forever. So we have to make sure that whatever is the shortest path among the vertices, that one should be processed first, so that if 0 to 2 was 8 but this was 5, so then we will process accordingly. So this is the whole point, and then this will continue for other, like if the graph is bigger or whatever. So that is the whole point why we anyways we are storing the weights as we we are putting it in an array like 0, 1, 2. Initially this is infinity and this is 0, and then we will updating. This is fine, but we also have to use a priority queue. Okay, because here the order of traversal affects the algorithm. So, and it's important to choose the order of traversal where smallest weight vertex is processed first. And even if you see, we are processing the source first. We are not processing from here. We are processing 0 first, because 0 has the smallest weight with itself. It is 0. So that's why these two things are important. Now once you know this, there is no issues. You can understand Dijkstra, that why we are using a priority queue.